When you think about energy storage, you probably think about batteries and how they store the energy, or hydropower stations and how they store high amounts of water that can be later used to produce energy. But you rarely think about thermal energy storage, which is more common than you would have expected. Thermal energy storage is a process that involves the accumulation of energy through heat. Uh, Thermal energy storage stores the energy during periods of low demand and uses them later when the demand is high. There are three types of thermal energy storage: sensible heat, related with the heat capacity of the materials; latent heat, related with the phase change materials; and thermochemical, which is related to the chemical reactions between the materials. In this video, we will be discussing a bit more about sensible heat applied to district heating and cooling systems.
Now, now, let's dive into how sensible heat storage works in a practical use. In sensible heat storage, thermal energy is stored by increasing the temperature of a material, typically water, without changing its phase. The formula for calculating the energy stored is Q equals M times Cp times delta T, where Q is the energy stored, M is the mass, Cp is the specific heat capacity, and delta T is the temperature change. Water is often used because of its high specific heat capacity, meaning it can store large amounts of energy for a given temperature increase. This makes it highly effective for district heating systems. The system works by heating the water during off-peak times when energy demand is low. The water is stored in a large, insulated tank to minimize heat loss. When demand rises, like during the morning or the evening, the stored heat is released into the district heating network to supply buildings with warmth. This process helps reduce the need for constant energy generation and allows us to use renewable energy more efficiently, making district heating systems both cost-effective and environmental friendly.
Hello everyone, this is Umme Salma. Now I'm going to talk about the benefits of thermal energy storage in district heating and cooling systems. Thermal energy storage plays a transformative role in district heating and cooling systems by offering several key benefits. It enables energy efficiency by storing excess thermal energy during off-peak times and utilizing it during high demand periods. This reduces the need for additional energy production, saving cost and energy. It also supports the integration of renewable energy sources such as solar and wind into district systems. It stores renewable energy when it's abundant and uses it later, enhancing sustainability and lowering carbon emissions. Furthermore, thermal energy storage provides grid stability by reducing strain during peak demand, helping to avoid costly infrastructure upgrades.
Now over to some challenges for sensible heat thermal energy storage in district heating and cooling systems. There are four main points, and here's a picture. The first one is space requirement. Water is often used as a storage medium, and this requires a lot of physical space. We have thermal losses, operational complexity, and very high cost. Future developments in sensible heat thermal energy storage in district heating and cooling system will focus on improving the insulation materials, but also looking for alternative materials for the storage medium, ones that require less space, so we can reduce the space requirements and also the thermal losses. There's integration with renewable energy sources, control system and hybrid storage technologies, and this will also enhance the flexibility and the efficiency of the systems. And this was our video. Thank you for watching.